Good afternoon. I am Gino. This is Dirk. We are sharing a presentation about source control. Is everyone here using source control? Any who don't? I hope we can convince you during this presentation for start using it. We work both at user group in Belgium. Can you keep the questions for after the last slide, please? Some say, I have a daily backup. So you just keep copying the same project over and over again, underscore old, underscore older, underscore very, very, very old. Or you have a copy in Dropbox or in cache plan. So I don't need source control at all, I'm safe, aren't I? I work alone. I don't work in a team, so I don't have to check what another has done, what I do myself. I'm the only one working on this source, so I don't want to know what anyone else has done at that source. It was certainly me. It's way too expensive. It's too complex. I don't understand what all these functions are all about. And it's so much work. But did you ever come in a situation that you had a bug report of some bug that was probably introduced 2-3 versions ago, a couple of months? What was changed back then? What has changed in your code that caused this? Who did it? And why? These 3 questions are vital, because if you don't know this exact situation, you run the risk of introducing a regression. That will say you have fixed the bug, you worked on for 2 or 3 versions, and you reintroduced it. Customers aren't happy about that at all. That you have some developer claiming that he didn't cause that bug. Some developers are just perfect, they never type any bugs at all. Have you ever had someone asking you what was in your software changed? A customer who wants to know, why do I have to run this update? What is changed in it? What's in it for me? Are my bugs fixed? Is there some new functionality that I can take advantage of? Or the unasked question, what do I pay you for? Did you need to release a critical bug fix? Well, you have this customer or a group of customers who have a strange crash bug. Program keeps crashing, so they can't do the actual job, or it's miscalculating some things, or even worse, it's corrupting the database. And you are just in the middle of some new feature, so you have the choice. Release untested code, or untested code, unfinished code, or you just fix that, or you don't fix that bug and you say to that customer, well, you take 3 weeks off, maybe, that will cause it, that will solve the problem. And with these 4 examples, you'll probably have some other thoughts. And did you know it's real cheap? If you install it on your own server, systems like Subversion and Git, both are open source, they are just free. Of course, you have to pay for the electricity, but if you use a cloud solution like GitHub, it's free for up to 3 developers. From then on, it's $7 each month. So if you have a team of 40 developers, it's still $7. It's free on GitLab. as long as you don't need any support at all, or you don't need anything advanced, too advanced to be in most source control systems. It's free on Bitbucket for up to 5 developers. 6 developer costs you $12 each month. And from then on, it's $2 for each extra developer. But then again, if you have 6 developers, it will probably cost you more than $12 each month. If you want some more choice, here you have an extra link with some other cloud solutions. But wait, there's more. You can also use this for analysis or documentation. So if one customer says, I have this 2-year-old version of your software, do you still have the manual? Yes, you have. It's in your source control. And setting up source control can be done within minutes, like we are going to show you within a few minutes. So to end the sales pitch, why would you use source control? If you work in teams, it's almost inevitable. You can keep tracks of all changes that were done to your software. So you always know afterwards what was changed. By entering commit messages, you also know why it was changed. So there were 5 files changed, and you type a quick note. This was to fix this bug with this number in our bug tracking system, or this was to add some grouping of stock in that screen. Just keep it short and clear. You can undo almost everything that was ever entered in your source control, roll back any change. And then you have branching. Branching is a system where you can keep your source separated. This is production. This is with all our customers. This is the current version everyone is using. And this is development. So every brand new feature you are making in the development branch. If you ever need to release that hotfix to fix that crashing, miscalculating, data-eating bug, well, you just fix it in production, give your customer a new compile of your software, apologize of course, and you apply the same patch in your development branch and everyone's happy. You don't have to stop any development at all, do any rollbacks. No, you keep those two separated. And of course, you always have a backup. So, which version control do we choose? There are 2 major systems at this moment. First of all, you have client-server systems like Subversion, CVS, Microsoft Visual Source Safe. These are, like it says, you have your source locally where you're working on, but every change and every message and your entire history is on that server. Second system is distributed, where all those changes and the entire history is also on your client. Distributed systems, most famous example is Git. You also have Mercurial. Main advantage of client-server systems, you can put some file locking on it. This is a feature you can use when you have all your developers in the same room and your code is split nicely. Main advantage of this is you won't have any merge problems afterwards, where developers have to sit together. I changed this file, you changed this file. How do we merge this? And then you have distributed systems. Advantages, it's faster to commit. since you commit locally and then push it onto the server. It's also available offline since you have just everything on your laptop. And you don't ever have a single point of failure because your source is just everywhere. Both those systems are actively developed, as you can see. Both are frequently used by developers in combination with Xojo. Both can be used from the command line. This is the documentation how you can do that. But even more importantly, both have clients to make your life very, very, very easy. That is just point and click. These are two links with a comparison of different Subversion clients or clients for Git. If you have an Apple, just go to the App Store. Some are free, some are to pay for. So in short, between Subversion and Git, there are no bad choices. Git can be used offline, and Subversion supports file locking out of the box. All other features are available on both systems or easily configured in another way. Just one final warning about sharing code between multiple developers. If you ever download the code from your Sourcecontrol system, remember to close your Xojo, because Xojo keeps all sources in memory. And otherwise, if you don't do that, you will make the changes on the old version of your source, save it, commit it to Sourcecontrol. The developer where you just destroyed his last changes, he won't be happy. And Sourcecontrol will blame you in the history. So, and not anywhere to hide. So, first demonstration of how fast and how easy it is the GitHub system. That's cloud solution, Git distributed. You go to this link, you create an account by entering username, an email, a password, and push the green button. Then you can start a project. You enter a project description, a project title. Since you're doing this online, you have a few extra options that you don't have in the clients. You can make this a public project or a private project, and you can add a license. These are all open source licenses. So if you have a commercial license, then you can use that option. You can't use that option, but then again, your project will be private, of course. Afterwards, again, the green button at the bottom. Then you install GitHub Desktop from this link. You download for macOS. On Windows, it's the same button, but Windows, of course. And then you follow with it. You have to sign in with your newly created account. You set up your local project. Here you have some options. At left you have the repositories that you have already created. And on the right you can clone any repository from the internet that is available, or you can create a new repository from some source files on your computer. If you are here, you will probably have sources on your computer, so it's the plus sign. To clone an existing project of someone else in your own company, or you want to help with some open source project, like this public project of Camp-Tickenice Xojo was from a few years ago. You copy-paste that link to the URL. You say where you want to save it on your hard drive, and you push the clone button. And then you can start working on your project. First of all, you need to download the changes by pushing the Fetch Origin button. Then you can start programming. You open your Xojo, do all the changes. You can see the changes convenient list. You add a comment and a description of what was changed, and you press the commit button. Done. You can see the history, who has changed that project or that file. So again, there's nowhere to hide. If someone introduced a bug, and then of course you have branching, where you can create a branch, do the changes, commit to that branch, and whenever that new functionality is changed and is tested and goes to production, you merge it again with the button at the bottom into the master branch. So,
okay. So far we've seen Gino demonstrate how to work with Git. At work, we actually use the two systems. So Git is going to be for all our new projects, but we used Subversion for the previous project, mostly because we came from the visual source safe environment that Microsoft had, and our developers were, in those days, used to having the files locked. And with Git, you don't have a locking system. With Git, you end up merging code. So if you have merging conflicts, you need to manually look at it. And the people were a bit nervous about that, so we held off on that and used Subversion because that actually does support file locking. So I'm now going to show how easy it is if you want to work with something like this. So Gino already showed with GitHub, you don't even need to install anything. Everything's online. But let's say you wanted to install your own server, and is that something I need to be scared of? Well, let's see. We're going to show the commands you need to do to install Subversion on an Ubuntu server online. So first we install Subversion with the standard default apt-get command that Ubuntu has to install programs. So we ask for administrator rights by going sudo and apt-get install Subversion. But we don't do that. You can also access Subversion through a web interface. If you want to do that, you also need to install the libapache2 SVN module, and then you can use the Apache web server to access your SVN. You'll see how we access it in just a minute. So after it's installed, of course, you need to have some folders to put all your stuff in. So we create one for Subversion itself. So make directory on the local system. And we create a subfolder for our repositories. Don't worry too much about all the commands you see. The slides will be available so you can read it at your own pace later. But I'm just trying to show that it's not really that complicated. So of course, if we're gonna have users that need to access our version control, then you need to have a user group that will have access. So this command, we create the group, we called it SVN. And then we say, all right, so the repository needs to be owned by the people in this group. So change group SVN, that repository is now owned by the group. Then it wouldn't be much help if you couldn't write to that directory. So basically we give it the group write rights, so they can write all their changes to the folder. And of course, we don't want to set the rights for every new file that's ever going to get created. So we say that all the new files that will get created will also get the group rights. So here you can see that the user Dirk, which is me, in the SVN group has those rights. So read, write, and the new files will have the group settings in the repositories directory, just like I asked. Then I'm adding myself to the group because it's not much point to have a group if there's no users in the group. So add myself to the group. And then, and this is important, you need to log out and log back in to make sure that everything works correctly. And you check that by typing groups, and you should see SVN amongst the groups that you're a member of. So Dirk is a member of the sudo group and of the SVN group. So obviously that worked. Then we create our repository. So it's going to have to go in the repositories folder. So SVN admin create, and as you see, I named it my project. We're setting the group rights for the to the SVN group for that folder, and we say that the group has write access, and again that the new files will have those same rights for the group. And again, you can see, if you look at the My Projects subfolder now, so in the repositories folder, it's owned by root, and the SVN group owns it. And again, read, write, and new files will have the group settings. Then you need to configure your server. You might think this is going to be scary, but no, not really. It's just a couple of lines. So each repository will have its own configuration file. So there's no one default for everything. Everyone has its own. So you can see my project is listed on the screen, and then you have a conf subfolder of that, and in that one you find the svnserv.conf file, which is just a flat text file, so nothing special about it. And in that file we're going to say that anonymous access is not allowed. You don't want just anyone to log into the system and start doing all sorts of changes. So anonymous access, none. Then authorized access, they have write access, so if you're authorized, you're allowed to implement changes. And the password database is a file called password in this case. Of course, you name it whatever you want. But yeah, for the example, we're using passwd as the file name. So you can see it over here. So it really is just a flat text file with anonymous access equals none, anonymous access equals write, and over here we have the password database equals password. So just 3 lines we had to change, nothing spectacular, nothing to be scared about. Then we've changed the configuration file. We said there's going to be a file passwd, and so of course we need to edit that one as well. So that's in the same subfolder. So we open that one, and we're adding the user with this syntax. So it's super simple. This username equals, and that's the password. So again, purely simple text file. Dirk equals Dirk's password. That's not a good example for a password, by the way. Don't do that. It's just an example. And Gino equals Gino's password. So that's the way that you put users in the password file. Now, very important next step will of course be locking down access to that file, because as you can see, this is an old system and the passwords are in there in plain text. And then you would worry that we're going to access this over the internet, and maybe this is scary with those password files being that easily readable, and we'll see why that's not really an issue in just a second. So like I said, the passwords are stored unencrypted. You could read them in the file just a second ago. So it's important that you lock them down. If you remember when I showed a couple of slides earlier who was the owner of that repository folder, that was root. So we're going to limit the file so that it's only readable by the owner. So we do change mod to 600 for that file, and then you can indeed see that, so read write for root, and that's it. There's no other writes on the file, so no one else is allowed to access it other than root. Then you're going to want to have the Subversion server boot on startup, and so you can try to figure out exactly how you need to write a script that will boot it in the background, or you can just take it the easy way and download an SVN serve script. On this website, they have a very good example of one. You might think, maybe I can't trust this because I'm downloading something that's going to run automatically on my server. Well, it's again just a simple text file. It's a configuration file. So you can read everything that's in the SVN serve. I've used it myself. I've read the thing completely, and yeah, I don't see anything wrong with it. And since everyone else is using it and no one's complained on that website, I don't think there's a problem with it. But if you're in doubt, you write your own script, of course. Then you place the script in the init folder of Ubuntu, which is where all the initialization stuff will run. So we copy it to that place. We say that this file is allowed to execute, so change mod plus X, it's allowed to execute. And don't forget, we used the repos folder in our examples here. But if you used another name, and you're free to choose whichever, don't forget to change the file, because of course that's the one that they used. And then we just need to make sure that those scripts get installed. So update rc.d svnserv defaults, and it's installed. So basically it will start on the next launch of your Ubuntu system. And if you want to start it now, you just go svnserv start, and your Subversion server will be running. And that's pretty much it. So we went over that rather quickly, but it takes just about as much time for me to explain it than for you guys to run all this. So it really is about 20 commands that you need to execute, and you're done in about 10 minutes. It really doesn't take more than that. And it's just pure text files. There's nothing scary about it. And you can, of course, because it's a widely used system, find lots of people to help you in case that's needed. So estimated time to install, like I just said, about 10 minutes. So now that we have the server part dealt with, of course we want to be able to access it. At work we use a program called SmartSVN. There's other options available, of course. So I'll quickly run through that. So you install it. It has a professional edition. You can use it for free for 31 days. After that, you can still use it for free, but all the professional features will stop working. So you're going to have a little bit less functionality, but it's still usable. We do use the professional version though. Then, if you don't want it to send crash footprints to them, that you say, okay, we don't really want that done, that our data goes to another company, you can uncheck that. So that's what we do. And then, because we're just starting this up, we're saying, okay, it's already set up because we're going to import our first project manually. So you say, my repositories are already set up. Then in the file menu, you select import project into repository. You get into this screen and you hit OK. You select your local folder where you have your Xojo project. So just the folder where the project is located. And then you select your repository, and here's the thing about the online server that we're using. So you have the SVN protocol, but we're only using that to locally access it. If we're using it over the internet, we're not using that password file at all. It's irrelevant because we're going to connect over SSH. So we're going to have a secure connection to the server, and you can either use with authentication with a password, but we're using the public-private key combination. So you basically log in to the server in the normal secure manner that you're used to it. So you SSH into the server, and you provide your key file in case you're using a key file and your passphrase. And so when you do that, it does not use the passwords that are in that file. You're securely connected to the server, and it knows you're securely connected. It knows which user you are, so no use for the password at all. So you don't expose your password to anyone that way. Then, over here on the screen, we have a little folder with a plus, so we're gonna create the directory that's gonna contain our stuff. So we give it a name, test project. And we here give it a commit message. So I said create a directory test project, including trunk, branches, and tags. So that's the default structure for your project, so that you can branch like Gino said earlier. So that's just by checking that little check mark, create default project structure for trunk, branches, and tags, and you hit the create directory button. So the trunk is the main part where you're working, so you select that one. So that's where we're going to import all our stuff into the main trunk. Then basically we say add a new project, test project. By default it's in the sorted group. We leave that as it is, and we hit the import button to import our project into the Subversion. Then, of course, we've now put it into our Subversion, but we still need to commit it. As long as you didn't commit anything, there's nothing really final. So we're going to commit it, and we're going to say fully recursive, so it takes the folder with all the files and all the subfolders and all the files in the subfolders as well. So fully recursive, and we're going to commit it. And does anyone know what we need to do when we are going to commit? Do we need to add anything? Yeah, a commit message. So it's always useful to have a commit message that's relevant to what you're doing. So in this case, I'm saying initial commit. Once you got started, what's a good idea is never to commit too many things at the same time. Don't change 300 files and then say changes of this week, because no one's going to know what's in there. So no, you basically change a file, you commit that file, and you say, okay, this is what I changed and this is the reason. If you have a ticketing system for bugs, you say, okay, I'm referencing this bug, that's what I fixed, this is how I fixed it. Just a short message and commit it then. That means later on, if you go through your commit messages, you can actually see what you did and why. And of course, if you have 300 files that changed in one time, there's absolutely no way to keep track of it. So you might as well not use any version control then. And then we go into the optional step. This is not required if you use Subversion, but as I said earlier, our developers came from Microsoft's system where that file locking was always in place, and they were very uncomfortable. If they were going to work on a file, they didn't want someone else to be working on the same file at the same time, because then you end up with the merge conflict. You solve that problem by locking the file. So if you have it locked, then let's say Gino has a file locked, and I'm looking in my Subversion listing, and I'm seeing, oh, Gino has this file locked. I can say, Gino, do you still need that file? And he can say, yeah, I'm still working on it. Or he can say, oh, no, I don't need it anymore. And he can commit his changes and unlock the file so that I can lock it and I can work on it. But there's no way that two people can work on the file at the same time if it's locked, which works around the merge conflicts that you might be able to have. So if we're going to say that it needs a lock, we select our files that we just committed, we right click on it, and under locks we say change needs lock. And so again, it's not final because we've said it needs a lock, but we haven't committed anything. So again, we need to commit. So as you can see on the screen, it now over there says that it needs a lock, but we're going to have to commit it. And again, don't forget your commit message. In this case, I said needs lock switched on. If you create new files later on, sometimes you created a new class and stuff like that. One thing that our developers commonly tend to forget is they commit their file, the new file, and they forget to put it to needs lock. So then we tell them you forgot the needs lock, and they commit that again, and then that's fixed as well. And of course, you saw me adding myself earlier. So I was part of the SVN group. I've done the initial commit. I've done the set the locks system. But we don't have any other members yet. So Gino was in the password file, so he already had access. And so if he wants to access it, he doesn't need to go through that whole procedure because everything's now already in the Subversion server. So check out project from repository is what he needs to select. And don't forget, we checked everything into the trunk, so the thing he needs to check out is the trunk so that he has the complete system. Of course, just like with Git, Subversion will show you the changes. So you have a column that says local state and you have a column that says remote state. So remote state is on the server. Was anything changed on that side, on the server side? Do I need to pull anything in from the server? Or what have I changed? The ones that you've changed, you will see the modifications right here at the bottom, so you can review your changes in the system. And if you work just on one project, Xojo will always tell you, you can work with their version control format. That's not what we do at work because we share code in between several different Xojo projects, and the easiest thing, if you want to do that, is basically make it into an XML external, and then you can drag all those XML externals into your other projects. But then, of course, in your Subversion, for the changes, you're not going to have the version control format, you're going to have an XML format. So there's a program, Jeff mentioned Thomas Templeman yesterday in the keynote presentation. He has a program called RBED, and you can actually link that to your version control system. So I've linked it here. Thomas Templeman has the parameters that you need to enter it here on his website. You will be able to find it in the slides later on as well. And we're quickly going to show what the difference is between those two. So you can work without RBED or you can work with RBED. This is without RBED, so you can see that there were changes. The file on the right has a couple of lines inserted, and it's in green, but everything says source line, source line, source line, source line. So it's XML, it's all the lines are encapsulated, and that means, yes, you can sort of see your Xojo code in there somewhere, but it's not all that legible. So if you do the same thing with RBED, this is how that shows it. So even though it's exactly the same file, it's the same XML file, now you can easily read your Xojo code. And you can see that RBED knows how the Xojo format works, so it basically is slightly easier to use that if you're gonna be using the XML format if you want to share code in between different projects. We've tried it several times to share code with the version control format that Xojo has, but almost every single time we do have slight problems with it. So last time I tried this like 2 months ago, and I reverted back to XML yet again because I still had trouble. See, on the right you can see that it's indeed just Xojo code that you have. So as you could see, we just went through the whole thing. Server installation, client installation. All it was simple pure text files. It doesn't take long at all to install it. So there's really nothing to be scared about, and especially if you want to be secure in your way of working, if you want to say, okay, in case I made a mistake in my code, I want to be able to roll back to before the mistake. If you are using version control, it's absolutely not a problem. If you don't use version control, you can hope that you have a backup. Maybe you have one, maybe you don't. If you have one, maybe it's one from 3 weeks ago, but the code that you wrote was 2 weeks ago, and you have to do it all again. This is not a good idea. It's a waste of time, it costs you money. So please use version control. We also, in those systems, have logs. So the log in Smart SVN, this is for one file. So you click on the file and you say, show me the log, and it shows you all the changes to that file during the past with your commit messages. Remember what I said about the commit messages, and make sure that they're to the point. This is where you're going to see what you changed to the file and why. Of course, you can double click it and see more information. So if you typed a little bit of longer text, you're going to be able to see it there. But that's the history of that file. That's very useful, but they also have, and they call this one a graph of the revisions. So instead of having the one file and the history of the file, you have the history of your repository and all the commits you did. And then, of course, if you made a mistake, you say, okay, roll back to this revision, and you're pretty much done. And you can start from there again. Or you can say, okay, I think I might be able to figure out from here and branch it, and work on the branch for a while, and then merge it back in again. That's possible as well. But that's a bit more advanced than what we were trying to explain today. So here in a bit more detail. So that says revision 4062, 4061, and so on and so forth. You can see which developer committed that. You can see when it was committed. And on the right, you can see, and that's what I said about if you have a ticketing system. This says ticket 31,853. So that's what they worked on. And what was it that they tried to do? If you have envelopes and you wanted to print to the envelope, that worked on Windows but not on the Mac. That's the bug that was fixed in that revision. So even though I didn't do that revision, I can see what they did and why they did it. So very helpful. Are there any questions? Yes? Could you say that again?
Well, why in those two systems? In Git you can have collisions, and in SVN you can't have collisions. That was the question? In Git you can have collisions because it's a distributed system, and you have the entire repository on your own computer. So you don't have a link where everyone connects to, who has those files, who is working on which file at that moment. In Subversion you have client-server system, so the server controls everything. That way, that server can say, yes, if you want to work on that file, you have to lock it, otherwise you don't get it. You get a read-only copy to work on, to work with, but you won't be able to change it. On Git, you can't lock a file, so basically you can have merge conflicts. Merge conflicts, I didn't see any trouble yet with them. They can take some time to figure out this developer did this change, that other developer did on that same source file another change. Well, at that moment, they have to sit together. Why did you do that? Why did I do that? And solve the conflict. In most cases, Git is quite smart, and you won't have trouble at all. But in case you do have trouble, you have to sit together and work it out. Yes, it's because Git is not local. It's distributed. So you have an entire copy on your own computer of the entire source control, with everything that has ever changed it, with everything that ever changed, and every developer's changes. So that's the reason why you don't have locking on Git, and you do have locking. You can lock your files on client-server systems like Subversion.
Other questions? No other questions? Last call? Thank you very much.